Hello, how is everyone doing? Welcome to the Friday stream. Yes, we made it yet another week and zero progress. How is this possible even? I have no idea, but today there will be progress, I promise you. Today I have something new. I just received this encoder. Yes, yet another encoder, I know, we have so many already. But I really wanted to give it a shot. This one is EC11. And looking at it, it seems to be rather short. Let's compare. This is our magnetic encoder, AS5600. So this is technically a different part, the one that I just broke before the stream. But more or less it should be something like this. Or maybe more like this. Looking at it, yeah, because of the magnet. So either way, should be this thick or maybe this thick, doesn't really matter. But what matters is that if you look at it, it doesn't seem to be that much of a difference in height. Maybe just a little bit. So looking at it, maybe we can just go something like this. Yeah, so I got two different versions. This one sadly is an SMD or SMT version. So as you can see, it doesn't have a proper legs. It's meant to be surface mount. I also bought one that has normal legs that should be able to mount like through hole. Sadly, it didn't make it for the stream. Hopefully next week. Maybe even tomorrow. Would be very nice. We can give it a shot on Monday, and I assume there will be similar size, so that would be easy fix on Monday just to check how it's gonna look like. For this one, what I would like to do today, I would like to make a proper extension, volume extension. It's very nice. It has a switch just like all the other encoders that you can buy like this. We're not gonna worry too much about this. Actually, it might even come handy, the fact that it's a surface mount, because maybe later on, when we try to do a proper PCB, then this will definitely come handy. Might be better fixed than through hole. Yeah, so as I said, it's not too tall. We can give it a shot. We can make a proper knob for it. We can try to figure out how are we gonna place it in our extension, because like we definitely gonna need some kind of a support, maybe from the bottom, because there will be some wires coming from here. Good thing is that it has, as you can see, you can solder from the top, you can solder from the side as well, although there's not that much surface over here. But you can also solder stuff from the bottom, so that's kind of might be helpful if we do like hand wiring. What we gonna try is to kind of make like a mount that will like go around it. Yeah, we'll see how it goes once we get into DesignSpark. And then if we are lucky enough and finish the mockup before the end of the stream, doesn't seem like too much work. Then in the meantime, because we kind of skipped it last time, we managed to get the MT6701 kind of working in QMK, because it turned out that in analog mode it has the same output as any other encoder, like this one. So you can just like wire A and B outputs to like the same way you would wire like a standard encoder, and then you can read it directly from QMK without any changes to the code. You can just use it as a normal encoder, which is kind of great. One thing that I didn't like about it was that without the magnet it was kind of going crazy. So maybe before we dismantle this one, I was thinking if we do like a pull up or actually a pull down, because the signal is like positive, so maybe we can pull it down to ground. We can use two resistors like 10K, should be good enough. And maybe this will prevent it from spamming when there is no magnet. I hope this is how it's gonna work. If not that much of an issue, because like in a fully assembled keyboard we will have the magnet on all the time, so maybe it's okay. Yeah, so we can do that as a side quest. And then if we still have time, I forgot that we are supposed to try and read this one, AS5600, because this one doesn't have a analog output like the other one. So this one we have to read via I2C. There is a register for that. I already have a working version in Arduino, which I showed you last time. So that shouldn't be that much of a problem, I guess. Like the logic is there already. Just we need to see if it's possible to read those registers with the standard QMK I2C API. I hope it's gonna work, no problem, because like if you can read anything else, if you can work with for example OLED display and some other stuff, I2C expanders, you can read the registers from there, so it shouldn't really be any different trying to read from this one. So yeah, this is another side quest. So without any further ado, let's jump into this thing. I think I got a message, 1 second. Yep, okay, so how we gonna go about it? Maybe first let's take a look if what's the size of this thing. So like the bottom part where we have legs, or maybe connectors, it's a more proper name for that. So it's like 15 a 15.7. Okay. Also, before the stream, I did some googling and I found this datasheet. So looks like this is datasheet for exactly this encoder EC11. One thing that is kind of weird is that I can't really see it over here. It looks kind of different because we have this this bottom over here. Let's zoom it in like this. So looks like we have this encoder but with a different head. This one is D-shaped, and we have knurled, or whatever it's called. We have this kind of a head, but then the bottom is different. So maybe it's not that much of an issue. Let's see. So there are some dimensions over here. But I can't see surface mount anywhere. Yeah, that is kind of odd because I did SMT version over here. So I did a search. EC11, yeah, so it should be surface mount. So we have two results, but among those results, all of them are not really surface mount, unless there is a different... Oh no, there is... This one is surface mount. Okay, so yeah, a little bit further. Something over here. Yeah, but still it's kind of different. This one looks nothing like this. Oh well, buying stuff from AliExpress. Yeah, it looks more like this one, just that we have an SMT version. Alright, wow. So I think we'll have to do with just like manual measuring. Okay, let's jump to DesignSpark. Let's make new one. Let's do EC11. And we're gonna do SMT for this one. This one we can hide for now. Okay, so let's take a look. So looking at the base, so this one is 15.6. Let's do it like maybe 15.7, maybe 15.8. Then this will okay. Okay, I'm gonna do it 15.7, but then I will have to remember to add a little bit of a margin to it later on. So okay, so this is 15.7, and this way is 12.2 maybe. Okay. So we have 15.7 and 12.2, if I remember correctly. Goldfish memory. Okay, now it looks like it's a little bit less. Okay, 15.7, that is correct. And this way is... Okay, there's a... Okay, I got it. So the measurement is a little bit different because there is this, whatever it is, thing over here. Okay, so let's do it 12.2. Okay, so that should be okay. Okay, so let's take a look on the thickness of this SMT legs. Okay, it's like 1.4. All right, so that's the base, kind of. Okay, so then we have 12.2. Let's do it from the center. 12.2. Yeah, something like this. Oh, what's the thickness? Okay, 3.10. All right. Then we have shaft over here. So the shaft is 7 millimeters, and then this one is 6. Okay. And what's the height of this thing? If we can only measure it somehow. Okay, 4.4, or maybe 4.5. So it was 7 and 4.5. And then we have like the mounting part. So this is where we can technically attach the knob to this one. So this one is 6. So this one is kind of standard. I think all of them have this part 6 millimeters. I remember making like 6.1 opening usually. Alright, and how big is it? Not gonna measure like this, maybe 5.5. Okay. I would like to maybe, should I give, okay, it's not important. We don't really have to make this opening. Okay. So this is how it's gonna look like. Okay, next step. Next step, we would need to copy like the whole base. What do we have over here? Okay, we can copy this one. Let's move it to the center. Okay, how are we looking? Okay, so do we have any distance from here? No. This is 0. We have to think about it a little, but first, because like the thing is, we're gonna need to wire this thing somehow, right? So we can, most probably we won't be able to use this top part because I would like to make some kind of a holder for it. So this holder, in my opinion, it should look something like this. So as you can see, this is the top, right? So there will be knob over here. So we need something to hold it. So it should be something like this over here. This will be open, something like this maybe, to fit in the shaft. Yeah, so okay, something like this. So this will be, let's pretend that this region is filled. So this will be holding it from the top in a way. We need some kind of like a mount over here. And then we also have to, because usually these encoders, they have over here on this part, usually there's a thread and you can kind of screw them in. The small ones, they don't have that. So we have to kind of lock it without the thread. So that will be like one part. Then of course this is the bottom of the keyboard, so I already see that we need to lift it up. because over here we will have the base of the keyboard. That will be like the bottom plate. So there is no space left for the wires. So I think we should lift it up to this level. So this is the level where the wires go, the wire canals, right? So if we lift it like this, so then on our bottom plate we need some kind of a support, something like this, because otherwise, if it's gonna be a little bit higher than the bottom, so of course, obviously, if we press it from the top, we're gonna just press everything inside and it will kind of like hide, which we don't want. So then we're gonna be needing some kind of a support from the bottom. So when we put together like the bottom part and the rest of the keyboard, so this should kind of get close to the bottom of this encoder, and that should be it. That should be enough, so we won't be able to like move it, hopefully. Okay, so as I was saying, let's move it up a little. Okay, do we need to move it like all the way up, or maybe we can just leave it maybe like halfway? Okay, we can save, I don't know, like 1.2. What is the height of this? Okay, 1.2 millimeters. Oh, okay, that's fine. Let's say should be okay. Okay, base. So now we need to make let's call it mount. So this mount, how can we approach it? Let's say we can maybe do a section. Can I draw like that? Okay, like this should be fine. So let's do like 0.05 over here. Like a tiny offset. I think so, like 0.005 on one side should give us 0.1. Okay, maybe let's do it 0.1. Let's not be too greedy. Okay, like this. Okay, and this part is where we're gonna be soldering stuff, so we don't really need to do anything over here. Okay, let's connect these two. Okay, now it makes me think most probably we will need to go from here all the way to the edge. It depends how we want it. Okay, let's do 0.1. Just for now, we'll see how it goes later. Okay. Over here, let's remove this. Let's go all the way to here. Let's get rid of this one. I think what we can do is just to do like a revolution. So we're gonna make like a half, just a surface, and then we're gonna rotate around the encoder. So this should give us like a full feature. this one from here. Okay, is it enough? Yeah, should be good. Also, okay, that should be enough because there is over here the shaft starts somewhere around here, so we'll have enough space over here to accommodate for the click because it has a switch. So even if we click it, it will be still a little bit higher than this. Okay, let's take a look. So now let's do pull, and over here we have revolve, and we can select this and we can use this. This will do like full pull or like 360. Okay. So this is how it looks like. Yeah. So maybe now let's take a look. I can do like a tiny mock-up. How would the bottom look like? So this way we can get like a glimpse. Okay, let's do from here. It's gonna be like this. And I think the bottom was 2.4, 3.6, so it doesn't really matter. Yeah, and over here, what we need to do, okay, there's one more thing. As you can see, it has this kind of, I think that for SMD or SMT, usually they have some kind of mounting mechanism, right? So what you will do, you will solder on the sides over here, and then on the PCB you will have holes for this. And this will like go in and prevent it from sliding. All right, so what can we do about it? Well, it looks like this is in the center, right? So let's see. It's like 1.2. by 5 by 1.2. Okay. What we can do over here, let's add that. So in the center, let's do just like 1.2. Well, we don't really need, like, we're not gonna be making holes for that. I just need to like avoid this level, I mean avoid this. So that will be 1.2 by 5.5. And what's the height of this thing? Okay, 0.76, 0.8. Ah, hey there, Stevenstein. Yo, man. Yeah, I'm doing fine. Finally Friday. We can have some rest over the weekend. It was supposed to be 0.8. Yeah, not done yet. Still need to do some prototyping with the encoders. Like, I got a new one. which is this one. Let me show you. We have this kind of EC11. So yeah, that's good. That's good. Have plenty of rest for the next week. Alright, so we have this thing. So maybe this one. Oh, that's cool. You have a color or just one color? You have like the, how it's called? Filament switcher, right? Or something like that. Ah, okay, yeah, so even more work. Okay, so over here we can do like a tiny margin, let's say 1 millimeter maybe, and then we can make a rectangle over here, and this way we can pull it up all the way to here. I don't have any chat commands, if that's what you're looking for. Okay, so this should give us support. Let's take a look how it's gonna look like. Oh yeah, exactly, something like this. Yeah, this should be okay. Okay, now let's think about it for a second. Okay, so, well, actually, the mount is gonna fill almost everything. Let's bring it back. Okay, so we do have some space for the wire. We just need to remember how to route it. Okay, it doesn't look that bad. It makes me wonder. Let's take a look if you would like to make a knob for it. Let's see, maybe we can steal it from this project. Right. It's a little bit too tall. We have to lift it up. let's do one. So this will be 6 millimeters. Yeah. Okay, so we need something like 6.1, and then maybe let's do it like 2.4. What's the height of just this little thing? Four 5.5. 5.5. Okay, something like this. This should hold it okay, but maybe we can kind of modify this a little bit so it won't be this difficult to attach and detach. Let's think about it. Like maybe we can just make an opening like this and like this. Let's see. Okay, let's try. Maybe we can do rectangle like that. Let's do 1.2 maybe like this. And 1.2 over here. Okay, not so bad. Okay, it looks kind of nice. It was a quick fix, it would seem. I wonder what I missed. So that's the base mount. All right. Okay, makes me wonder what is the depth when we press the button. Could it be it's like 0.5? Yeah, it looks like it's more like 0.2. Okay, so I assume if I make this, I can move this, maybe let's do like 0.4 from here, so that will be like 2 layers. Does it look kind of tall? We can compare that maybe with what? With magnetic encoder? Okay, so magnetic one seems to be a little bit smaller, but not by much. From this one to here is what? Okay, 3 millimeters. Okay. Can we go lower? Well, we could go lower, yes. Maybe if we just like push it all the way down, but then we're gonna be needing some stuff on the bottom, like for the wires. So maybe that is not the best option. Also, this mounting mechanism, like, do we really need it to be this big? I don't think so. I mean, it doesn't have to fill the whole thing. All it needs to do is to kind of hold it, right? Let's take a look over here. Let's just transfer the holes. Okay. Yeah, I think we can make it smaller, right? Maybe it doesn't really have to be like this. Let's see, if we go about, let's say, I think I forgot to make some space over here. Okay, let's do something like this. Let's make 0.1 from here. And from here, let's make maybe, okay, 1 point, okay, make it 2.4. That would be okay. 1.2. Okay, something like this. Yeah, it doesn't really have to like fill the whole space, right? All we need is just to keep this in place. And basically, we don't even need like, we don't really need all of these. Maybe we can make it even smaller than that. This way we can have access to the sides. Yeah, I forgot about. We have to pay attention to this mounting thingies. I mean, of course we can cut them, but maybe we can use them in our projects. So let's take a look how big these are. Okay, like 2 millimeters. So let's say we can do maybe like a 2.5 opening. And what's the height? Okay, it's 0.5. So over here, we can do something like this. Let's make a rectangle from the top. And that will span like throughout the whole kind of, how to call it? Like the holder, maybe? That will be our holder. So let's make it 2.5 so we can fit this. Maybe it's gonna be too much, 2.5. Okay, let's do it like, let's make it 2.2. Like this. Okay, now we can do minus 0.5. Minus 0.5 over here as well. Yeah, I should have kind of maybe add them over here. That was 2 millimeters. That was 0.5, something like this. Okay, what is the length of this? Okay, 1.7. We can make it 1.7. Okay, so you have a pretty nice mock-up. And actually that's good that I made it, because now I can see that if I would like to hold it like that, these are actually on the bottom, right? Okay. I think we need to remove this and only keep these walls over here, because over here we have the connectors, right? So we need full access, and on the sides we can leave it like that. So that will be the part that will be holding it. And do something like this. Where are we? Okay, perfect. So this should be enough to hold the whole thing in place. Maybe we can move this wall a little bit back. Let's do 2.4 maybe. What's that? Cool. So we can begin. Okay, so that's this thing, 6.1. Okay, so that is kind of a neat actually. When you look at it, yeah, it looks like a nice fit. If we drop it over here, so we will have plenty of space. Okay, what's the height of this? 0.8. What's this distance? Okay, so it's 0.8 from here to here. Yeah, I'm gonna leave it like that. Although, what's the height of this? Okay, 0.5. Okay, so this should print all right. Southeast Asia. Okay, I will take it as a compliment. German. Yeah, okay, German is fine. I don't really like it over here. Something is off with this. Can't really see what is happening. Hold on, okay, maybe it will be fine. Okay, does it mean we are good to print this thing? That's quite a distance to Bali, depending where you're from. How long is the flight? Okay, I think this one is good to print. I'm kind of curious. Technically we can do the bottom as well. Let's see if we can drop the holes. Okay, maybe these only. What's the size of this one? 2.9 or 1.9? Yeah, indeed. Yeah, maybe because of the holiday season. Probably a lot of people from Europe flying to Bali and to Southeast Asia, maybe as well for Christmas, I guess. Okay, I think we can print this thing. Okay, let's see. SMD. This will be bottom. And this will be our mounting stuff. Okay, EC11 SMD mount. No, I mostly build keyboards, at least on the stream. Stream is about keyboards, but sometimes I build some other stuff. That's the mount. And the base. The base should be like this. Empty base. All right. Base, and we are left with the knob, right? Okay, I hope this knob will work. EC11 SMD knob. Okay, there we go. So we have full stuff done. Okay, was it? Okay, it's visible over here. Alrighty. One thing. What happened over here? Let's move this one. This one. Yeah, STM32 is also used in keyboards quite a lot. Yeah, it's good to have some side projects, do something outside of work, otherwise it will go crazy, most probably, quite fast. Okay, does it look okay? I think it looks okay. Alright, what should I do? I think there is something on the build plate, let's take a look. Was there? I was printing a mock-up of disk drive. Yeah, okay, let me clean it, I will be right back. Yeah, I also do 0.2 most of the time. I always go with 0.4, standard one. I did buy 0.2 when I was doing the horizontal encoder, but then I realized like most people won't bother to swap the nozzle just to print encoder, so I went with 0.4 and it kind of works, so it's fine. I think I have a very old filament. Seems to be delaminating. I mean, it is very old. It was sitting in the box for quite some time. Let's see how it goes with this one. Okay, I think that should be it. Okay, let's send this. I'm kind of worried. Quick fix for this one part, and it took us an hour. So yeah, not so bad. Okay, so while it is printing, oh no, it looks like it's gonna take 1 hour, not good. Okay, right, not to be worried, we still have a side quest to do. Okay, so this encoder can wait. So let's take a look at this one. I think we still have there is still firmware on it, if I remember correctly. Okay, that's not it. I think that was the holder. Yeah, perfect. Okay, have this, and the knob was here somewhere. I think I lost the magnet. Let's see if we can. Okay, managed not to break it. All right, so let's do a quick check one more time. Let's see, we are over here, and I think we can do Notepad maybe. Okay, let's keep it on top. All right. How big is it? Not too big, sadly. Okay. All right. Yeah, so let's take a look if it's gonna work. Was working last time, so I'm not expecting any trouble with it right now. Okay, so let's see. We should get something out of it. Nothing. Okay, that is interesting. It looks like we have everything. Okay. Why there is no output? One more try. Why is it always like that? It was working okay, now it's completely dead. It was supposed to be so fast, just to check if we can pull up those outputs and see if they won't be going crazy like without the magnet. See if we have connection everywhere. So volume, voltage. Okay, ground. Okay, ground check. Okay, this is alright, and switch. Okay. So maybe let's plug this thing on. And there's no output. I can't remember, I didn't change the firmware. I haven't uploaded anything else on it, so it should be okay. Actually, I'm very surprised. There is no output at all. Okay. So we do have power, right? So it should be okay. Okay, I think I disabled it. Yeah, right. Okay, let's go back. I'm gonna put the magnet on. I think what I did, because it would spam, and we were trying to test the switch functionality, which didn't work because it has very odd timings, so I think we have to skip that. Yeah, so there is nothing here. Okay, now this one is okay for the encoder. Okay, this should work. Let's take a look if I still have my machine mounted. Okay, So what can we do? Let's upload this to the VM. There we are. Okay, what's that? Okay, that should be the correct thing. Where is my QMK? It's over here. Okay, let's do auto flash. Okay, that's the one. And okay, let's flash. Okay, flashing. Okay, flash is done. Let's see now. Okay, we have A and B. It's so sensitive, my god. Yeah. So let's go with the notepad. Okay. Let's keep it on top. Yeah, it's definitely too sensitive. Okay, what I wanted to check. So now if I remove the magnet, it's gonna go crazy. Yeah. All right, so let's take a look. I hope that if we do a pull down for A and B, so A and B are these two. So if you pull them down, okay, VCC is here. Okay, we have to pull it to the ground. Okay, we have one more ground over here. Let's just make sure this is a ground pin. Yeah, so that's ground. Okay. I need 2 resistors. I think I need to buy more resistors. Slowly running out. Okay, I will take 2 10K. Okay, we can connect them on one end. How can I go around? Maybe connecting them together wasn't a good idea. Okay, so we have to connect these two to this one. That is a little bit too short of a distance. It might be a little bit troublesome. How about we do it maybe here? Here we have ground. We can try. Let's see. Okay, maybe if I just go from here, so pin number 2 and 3, these are the ones that are A and B. So I could technically connect maybe to this, the ground. We've been using that for the oscilloscope. So this should work, kind of. Let's flip it. How's the print going? I forgot to show. Yeah. Okay, not so good. Okay. How much longer? Just like 1/3 done. Okay, one is done. Kind of good idea to twist the like this, and then I can hold the wire that is down there. This one didn't quite work. I think I'm touching. Okay, no. Looks okay. Let's take a closer look. Should be good. Okay, so I have something like this. This is ground, 2 times 10K, and A and B. Or let's okay, I think the mic didn't switch. Okay, before we can take a look if we really have it grounded through 10K. Alright, so from here to ground should be 10K. Okay, a little bit less. Okay, should be good. Maybe I will put the magnet on so that just to prevent it from going crazy, just in case. Okay, so let's turn it around. And if I remove it, no, it didn't really change anything. Yeah. So the pull-up didn't work. Yeah, maybe that is not that much of a problem. Okay, so let's take a look one more time on the datasheet if there's anything about this analog output. Alrighty. Okay, nothing about it over here. So A and B. So this is our output that we are using. Yeah, we can only change the pulse width and this kind of stuff. Resolution. It makes you wonder what's the difference between this UVW mode and IBZ. These look kind of the same. Yeah, let's take a look. I think we need to take a look how are they set up, which one actually is it. Okay, so this one, okay, we ABZ. Okay, so these are the same. Over here we have ABZ right now. So it makes me wonder which mode is that. ABZ, UV. Yeah, it looks like these are the same. Because over here it says it's like the same mode, right? So it's the same input, output 6, 7. Yeah, exactly. So I think we are currently on this, right? We have it. We have pin number 2, which is mode. We have it connect to the ground. So these are the same. Is there any difference between like ABZ and UWV? Okay, maybe we are getting more than that. I mean, because these are like 120 degrees out of phase between U and V. Okay, analog mode doesn't really interest us. Well, I am not using STM. I am using either AVR, which is Atmiga 32U4, but this one is kind of old. So recently I moved to Raspberry Pico 2040, which is kind of popular right now. So that's what I've been using. And yeah, I do make my own PCBs if I have to. Like we've been doing one not so long ago for Chordie actually. Try to see. Okay, so it looks like the pull-up doesn't work, and these two outputs, I can't really tell what is the difference between this one and the UV. A 1/4 cycle. It makes me wonder, are there like Okay, let's take a look at something. Well, yeah, but like RP2040, I think it's more popular. Aren't like STM boards more expensive than, for example, Pico ones? Like I think you can get Pro Micro with RP2040 kind of cheap. I think it's more or less the same price as for AVR. I might be wrong. Okay, what I would like to do, let's hook up oscilloscope and maybe we can take a look like what is the output of this thing. Would be cool to have just VCC. Okay, let's take a look. Makes me wonder how many outputs there are, like how many waves. Is there like just one square or is it more? Okay, I'm gonna be needing something. Well, I think Pro Micros with 2040 are less than that, maybe even half. We can take a look. Let's see, Pro Micro 2040. Oh, you're right, over here it's more expensive. Yeah, exactly, $11 for this one. If you go AliExpress, most probably it will be cheaper. Yeah, ESP32 you can get for like $1 even. I mistyped. Let's do Pro Micro. Okay, $3. So yeah, that is kind of cheaper. Yeah, but these are clones, of course. Yeah, but Spark Fan is $10. Very similar. Yeah, and how much you can do with them. Alrighty. I think before we proceed, maybe I will switch off A and B. Okay. I don't have an USB that is just power. I think I should get one. So this way, like I can sometimes connect some things and without any output when I just need the power. I can show you in a second. Okay, and just flash it. I think it's not outputting anything, so that's a plus. I'm using this one. Yeah, I think it's similar to what you're having, 100 megahertz, and also I don't think I will ever need anything faster than that. Yeah, I think it's Fenry, can't remember the name. It was rather cheap. It's very functional. I like it. For keyboards is more than you need. And the only thing I don't like is that it has a custom USB. I think this is micro USB, but like the socket is so deep So like if you buy a standard micro USB cable, it won't reach it. You have to use the one that came with the device, which kind of sucks. Okay, let's see. That's a mess over here. It can't even... Oh wow. So let's go again. I think this is some kind of like a broken output. If we hold it, yeah, we get something like this. But this doesn't even look like a proper output. Well, but that is not a clock. It's A and B output, but like without the magnet it behaves like this. And if I can put on the magnet, let's see. On bottom. Okay, so if we put the magnet on, where are we? Like this. Yeah, so how to make it? Okay, like this. Yeah, they're pretty cool. But I think it's an overkill for a keyboard. I find them too sensitive. Like this one, you just touch it and you already have an output. Okay, what do we have over here? That's the trigger. Yeah, when the magnet is on, there's no output on it at all. I mean, it's zero, right? So when I start rotating, so we get the square wave. Yeah, as you can see. Yeah, but right now nothing is happening, and if I just remove the magnet, it will go completely bonkers. Yeah, like this. So it's a complete mess. Okay, so I think we can stop on this. Let's take a look. Well, the good thing is that you can use this magnetic encoder without any code preparation, anything like that, because it has the same output. So as long as you have the magnet on, it works okay, just that it's very sensitive. So I think you can combat this with you can change the resolution maybe to like something high up, like maybe 20 or something. Then you would have to make like more rotation just to trigger it. I think this should work. Well, okay, one thing, let's take a look. Yeah, that's actually a good idea. Since we still have it assembled. Okay, where's my mouse? I'm gonna move this stuff from here. Too many windows already. Yeah, let's go back. Let's change this. And I think QMK has some kind of for encoder, so I think we can set resolution, right? So okay, encoder enable. Oh yeah, this one, resolution over here. So by default it's 4. So okay, how many pulses the encoder registers between each dent? All right, so for this one maybe we can, let's see, where should I put it? Maybe. Okay, config H. Okay, I have it over here. So this 4 is standard, right? So I didn't really have to put it here. Let's make it, I don't know. How about we do it like 12, for example? Makes me wonder how sensitive it will become after that. Because right now with 4, if I just touch it, I already have output. Okay, let's take a look. Compile. Okay, there's an error. We have an error somewhere. Right. This needs to be comment out. Okay, how's the compilation? Okay, fine. All right. We have to switch it off for a second. No, not really. I have yeah, because first of all on Windows, compiling QMK on Windows is super damn slow, doesn't matter what you use. So before I was running virtual machine on Hyper-V, but now I have a Proxmox server. So I moved this virtual machine to Proxmox, so it's like always online, so I don't have to worry about connecting drives. So I have QMK on this virtual machine. I have the source code folder on Samba, so I can just copy stuff there, compile over there, and from there I can flash whatever I need. It's flexible, more flexible, and it's super fast. And on Windows it was taking ages to compile code, so yeah, that's the workflow. Okay, let's put the magnet back on. Okay. Oh, it's still very sensitive. Let's see if I do Notepad. Alright, so that is kind of didn't really change much. So maybe let's go crazy. Okay, so far it's not triggering anything. How about we do it like, I don't know, let's do 360. Why not? Okay, looks like we can't go this high. Yeah, a lot of people moving away from Windows right now. I kind of understand that. Windows sucks with all this AI crap. Okay, so we can do 180. Yeah, I do play games from time to time. But not too often. Last thing I played was Expedition 33. Alright, we have this done. Okay, let's take a look. Oh wow, now. Okay. With 180. It doesn't seem to work. Let's change that. Let's do maybe 32. I think I went overboard a little. Let's see. Okay. How about now? Okay, what's wrong? Not sure what happened. Okay, it's not doing anything right now. Let's go back to 4. There we have output correct. Have I messed up something already? Okay. Oh wow. Alright. So let's go back and try to change that to 32 maybe. Okay, so now we have resolution 32. Okay, it's better now. Yeah, it's not that sensitive, but still. How about 64? Okay, flash complete. Alright, so let's take a look. Okay, yeah, 64 works nice. Yeah, okay. So yeah, even if you go like maybe 96, let's take a look just one more time how it's gonna work. Yeah, so the resolution makes it kind of okay. So yeah, that is like a feasible change if you would like to use it instead of a mechanical one. So this one works okay. We just need to do like a crazy high. Have I sent it? We just need to do like a crazy high resolution, and then it works okay. Let's kill this one and let's see. let's do like this maybe. So yeah, it's kind of all right. Yeah, so 96 for this is okay. Yeah. Okay. So that is a good thing in my opinion. So this can be used. All right. So what else? How's the print going? Okay, we have 5 minutes to print. Just clean this up. Right, one more thing I wanted to check, right. So one thing we did, we connect this, because I wasn't quite sure if the mode pin, if it's connected to the ground or not. So now it is. Now I have it connected correctly. What makes me wonder, if I remove this, would it still work? Would it still be outputting? Maybe this is not necessary, so this will kind of maybe help. Less wires to solder is always nice. Okay. Let's see. Okay. The notepad. Alrighty, and okay, let's plug this thing on. Okay. Yeah, it works. So we don't have to bother with changing this. So I was worried that originally, because I don't think it's connected to the ground. I think that was this pin, right? So yeah, there's no connection right now. And the pin number 2 is here, if I remember correctly. Yeah, so it goes all the way to here. That's the mode. Yeah, so by default, it's not really connected to the ground. Yeah. So the ground is over here and I'm touching pin number 2, which is mode pin. Yeah, so there's no connection, but still it works. So we don't really have to pull it down. Well, this might be not a good practice because like the rule is that you shouldn't have like a hanging pins, but isn't it like internally connect somehow? One more check before we move on. Okay, so looks like there is internally. Yeah, I said that yeah, great, is the game is awesome. Absolutely must play. Yeah, but as I said, I play a little. I don't play that many games. Oh, Lampmaster, it's at the beginning, right? This one is kind of easy. Okay, so this one is pulled up to VCC actually. Okay, so that is interesting. So if we don't connect this, then it should be pulled up to VCC, right? And this mode will be, this should give us I2C, right? But like it's not I2C actually. Okay, that is kind of odd. Well, it still works even without the pull down. The Yeah, that is interesting. And over here, I2C, we have to really connect it to VCC. Well, maybe 200k is rather high, so maybe if it's like hanging loose, maybe it's still like pulling it down. Well, anyways, it works, so we don't have to worry about that. Okay, our stuff just finished printing. I will just drop. Yeah, see you around. See you around, man. Okay, the issue is I have a very old filament and I think it's completely useless. It's like delaminating. Yeah, but I've been keeping it for like a year or maybe more, so no wonder it's useless. Okay, let's see what we have done, if it even fits. Oh, damn it. Yeah, and that's it, so it doesn't fit. Maybe I can rip this off. Yeah, I was right. So yeah, I can't really remove that. This one part was okay. So I was looking at it and I wasn't quite sure if it's okay or not. Now I know it's not. Yeah, so we can just pull everything down. We don't need that at all. Yeah. Oh, that sucks. Yeah, this filament is completely useless. Yeah, at least this part fits. So once I have this fixed, it's gonna be something like this. This one won't fit because, let's see. Oh, no, it seems to be fine. Yeah, that is interesting. So looks like we managed, even though like the top is messed up a little bit, we still have it. Yeah, it still fits okay. Let's take a look. If I attach, yeah, everything is falling apart. I just look at this shit. Okay. Yeah, don't mind. I see it's already, yeah, done. Okay. Cool. Design is almost alright. Filament is trash, so I have to get rid of it. Okay. I am kind of out of time already, but before I go, let's just finish this thing. Okay. Let's move this to here. I'm not sure what happened. Okay, let's go. Okay, that's our mount. Yeah. Okay, can I move it? Okay, I think we had some. After when we are doing this part, I think it kind of was projected to this, but that's okay. All right, like this, and I think these will be too high right now. Let's take a look. What was the size? Okay, 4.3. From the top. 4.6. Minus 0.3. All right, that should do it. Okay, I think we can finish on that. We are supposed to look at AS5600. We can do it on Monday. Yeah, there will be stream on Monday. I don't think I have anything on yet. So most probably you can meet then and we can take a look at it. In the meantime, I will try to print this. I need to change filament to something else. And yeah, maybe hopefully tomorrow maybe I'll receive the other one, the other encoder that has like proper legs. But looking at it, this one also doesn't seem to be too bad. Maybe we'll be able to solder something to it. Just a quick look at the bottom. Yeah, so this is kind of okay. What's the size from here to here? Okay, maybe I will make it a little bit smaller. It doesn't have to be this big. Let's make it 1.2. And from this side as well, 1.2. Okay, and this side is also very important because okay, this way we can do maybe 2.4. So this way, because over here on this side we will have the pins, so it's better to have it a little bit shorter so it won't be getting in the way when soldering stuff. Yeah, but other than that it should be fine. I think we should move it by 0.3 because we moved everything 0.3, so yeah, should be okay. All right, I will try to print it, see how it goes. On Monday we'll be working a little bit on this, maybe we can do the other encoder. And definitely we need to take a look at AS5600. Can we read it? Because this one we have to read through I2C. So we'll try to do that on Monday. Good news is that MT6701, we can use it without any coding, without anything. You can just plug it in, change the resolution for the encoder, like over here, to at least like 6496, and it works fine. It's actually quite nice. Yeah, so on Monday we'll have some more stuff to do. By then, enjoy your weekend, have plenty of rest, and I see you all on Monday. Thanks for watching and bye bye.